what we're going to have now is essentially a debate, but we'll have audience participation on the merit of the NASA's Asteroid Retrieval mission. As many of you may know, NASA recently put forward as a concept for a major mission to retrieve either we could call it a very small asteroid or a part of a larger asteroid, but anyway, an object with perhaps a diameter of 7 meters, not 7 kilometers, and using electric propulsion to tug it from a heliocentric orbit into a orbit around the moon, where it could then be visited by astronauts who would only have to do a 3-day flight out from Earth to go visit it instead of a multi-month flight to explore an asteroid in interplanetary space. So that is the basic concept, and it has provoked a sharp disagreement as to its merit. Is this a good idea or not? One panel in the Congress approved funding of it. Another unanimously, I believe, or in any case with a strong majority, voted for no funding for it. So maybe people just don't understand it, and that's why some people don't support it, or maybe the people who support it don't understand it. In any case, we want to try to examine this issue. And, okay, now I did write an op-ed in Space News that was very sharply critical of this mission. It was entitled NASA's Asteroid Absurdity, where I attacked it on a number of grounds. John Brophy, who's with me here, he spoke earlier today. As you know, he is an expert on electric propulsion. He was one of the principals in design of the electric propulsion system that has been successfully used on the Dawn mission. And electric propulsion plays a key role in the asteroid capture mission. And I believe that you were also involved in the design of this mission concept. Okay, so he is a strong advocate of this mission. He sees a lot of merit in it. So since you're with the affirmative, why don't you go first and explain why this is a good mission?
Okay, so let's see. There's a variety of standpoints to consider this, but we'll start first with solar electric propulsion because that's really my expertise. NASA has had for a few years now plans to do a high-power solar electric propulsion system demonstration, something on the order of 30 kilowatts or so. And the reason for that is there are lots of potential applications for a high-power solar electric propulsion system. And as we pointed out this morning, there's the need for a stepping stone to significantly higher power levels to support human explorations, either back to the moon or to provide cargo delivery for Mars missions and so forth. And it's too big a step to go from the Dawn-sized electric propulsion systems to these multi-hundred kilowatt systems. So NASA recognized that and said, okay, we need to do a solar electric propulsion demo of around 30 or 40 kilowatts, something like that. Problem is, that's an expensive demonstration to do, and that demonstration mission was slipping to the right at a rate of greater than a year per year, which means it was never going to happen. And so the so this mission concept needs high-power solar electric propulsion. It is enabled by that. In fact, most people, when they first hear about it, say, we're going to do what? And they think it's really a wacky thing. And so I'm not surprised at the reaction. Most people have that reaction because they think, you know, can we really do this? So, but it is enabled by high-power solar electric propulsion. And in fact, if you think high-power solar electric propulsion, which is, in my view, the most capable propulsion system for in-space operation that that has been developed to date and is getting much better at a very fast rate, that if you need that system for future human exploration missions, this asteroid mission is pulling that demonstration forward. It's pulling it earlier in time as opposed to letting it slip out more than a year per year. So that's from just the strictly propulsion transportation perspective, it's a very good thing to do because it allows NASA an affordable way to do that demonstration mission, which otherwise wouldn't happen, and makes all the other human exploration missions much more expensive in the future. There is a reason that all of the commercial ComSat manufacturers are flying solar electric propulsion. There's a reason that Boeing is going to an all-electric spacecraft bus, that all of the spacefaring nations are flying electric propulsion. It's because it is the most affordable way to get around the solar system. So the demonstration mission, pretty much most people, I think, agree with. Capturing an asteroid and bringing it back to cislunar space or translunar space or whatever the right buzzword is, that provides a significant real benefit in this cost-constrained environment in which it provides a meaningful destination that's reachable by the SLS and Orion that are currently under development by NASA. They need no other elements than those two, and they can go to a destination and do something meaningful in human spaceflight for the first time in a long time. It'll put them in contact with only the second celestial object in human history, and the first new one in 50 years. And it allows them to, it'll be, the farthest people have ever been away from the planet. It allows you to figure out how to deal with an object in a low gravity environment, how to anchor to it, how to deal with the dust and so forth. But also it has the potential to capture the public's imagination. This is a really outrageous kind of mission to do. It's something that most people didn't think was possible. And basically you think, well, we're starting to rearrange the solar system for the benefit of humanity, if you want to get kind of grandiose about it. But, and there are several other reasons, but I'll stop there and give you a chance.
I believe that the form of the argument that John has just advanced, while it is popular at NASA, is the wrong kind of argument to make for a mission. That is, you don't do a mission to give the things you have something to do. Okay, that's make work. Okay, in other words, to do this mission to give electric propulsion something to do this mission to give the SLS and Orion something to do. Okay, to me, it is the wrong way to conceive of planning a space program. Rather, what we need to be doing is think about what it is that we want to do and develop the systems that will allow us to do that. That is, we need to be mission-driven rather than constituency-driven. In this case, constituency being people who represent various technologies or various development programs who want to have something to do. Okay? And now, so, if the robotic space exploration program has been successful because it has been mission-driven. Okay, they conceive of a mission. We want to deliver a rover to Mars, and therefore we need to develop this kind of landing system. Now, as we didn't deliver Spirit and Opportunity to Mars in order to give airbags something to do. Okay, we developed that kind of landing system in order to get Spirit to Mars. We developed the Curiosity landing system to get Curiosity to Mars. We didn't do that because there were people who had this idea about tractor rockets and stuff, and they really had to be given something to do. Now, the human spaceflight program during Apollo was mission-driven. We didn't go to the moon to give Saturn V's something to do. Okay, we developed the Saturn V and the command module and the lunar excursion vehicles in order to be able to have a set of tools that allowed us to do the mission that we had set for ourselves, which was to send people to the moon and back. Okay? And that's how that came off. Since that time, however, the NASA human spaceflight program has been, for the most part, constituency driven. Okay? And therefore, in other words, they fly the shuttles in order to fly the shuttles. And they flew 120 some odd shuttles. Okay? And 4 of those missions were really worth doing: the launch and repair of the Hubble Space Telescope. Okay. Others of them, you know, for example, the mission that the Columbia astronauts died on, is scientifically indefensible. It was flying Columbia to fly Columbia. Following that accident, therefore, the Gaiman Commission, which investigated it, didn't just criticize the engineering mistakes that were the proximate cause of the accident. They criticized the whole concept. They said, if you're going to engage and accept the risks and costs of human spaceflight, you have to have missions that are worthy of the risk and cost of human spaceflight. You must have clear and compelling objectives for human spaceflight. Otherwise, you shouldn't be doing human spaceflight. Okay. Now, the Bush administration sort of took that criticism to heart, or at least acted or pretended that it did, and said, okay, we're now going to come up with an objective. We're not just going to be flying people up and down to the space station because we've got shuttles and we have to give them something to do. Okay, we're going to go to the moon. Okay, we're going to build a lunar base. And this is our first step out there. Okay, now there are criticisms that one could make of that, but at least it was a clear objective. And there's plenty of criticisms that could be leveled at the way it was executed and so forth. But nevertheless, at least it was sane. I think there were mistakes made. I think the things that were done were wrong, but they were sane. Okay, that is, they had an objective, and they started trying to develop a set of hardware to achieve the objective. Okay. Then Obama let it slide for a year because during stimulus they just wanted to spend money on anything. But then in 2010 he comes and says, well, we're canceling this. We don't want to do this. Okay. We have a better idea. That was not invented here. We're going to send people to a near-Earth asteroid. That's much better than going back to the moon, because going back to the moon is going back to where we were. Going to a near-Earth asteroid is going beyond. We're going to leave the harbor and sail out into the ocean of the solar system. We're going to leave geocentric space. We're going to sail out there. And that has some merit, especially if you're thinking about going to Mars. You will have to leave the harbor. Now, my criticisms of execution of that in the years since it was announced, but prior to this announcement, is that it wasn't really pursued. Okay, if you actually wanted to send people to a near-Earth asteroid, you would say, okay, what's the hardware set we need? It includes a re-entry capsule. It includes a heavy lift booster with a Earth escape stage, an upper stage capable of trans-asteroid injection. And it includes a HAB module. And you say, that's the pieces we need. That's what we should develop. And you do that aggressively, and you don't just have this be a vision. Now, if it's proposed that this is going to do, that we're going to do this, then you do it. You don't just kind of talk about doing it, but not do it. But then it became apparent that they were not doing it. But furthermore, this mission plan was proposed, and it's certainly popular among electric propulsion community because it would give them something to do. But that cannot be the basis of a choice of a mission, that it gives certain people some business. Because the technologists are not, properly speaking, the constituents of a mission. The technologists are vendors to a mission. Okay, that's who they are. Okay, and to do a business, to do a mission, you have to buy things from certain vendors, but you don't do something in order to please your vendors. Okay, but furthermore, this mission plan undermined the primary rationale of the Obama asteroid mission, which was to leave geocentric space. and said, well, if you want to look at an asteroid, we can show you how you can do it without leaving geocentric space. You know, so it undermined the primary rationale. Other rationales have been advanced for this mission, that it will develop a technology for planetary protection. This technology is not appropriate for planetary protection. This is a 6-meter object. If you want to deflect a 600-meter object, this doesn't have a chance, and on any reasonable scale. And even stopping the tumbling of such an object is impossible with electric propulsion. If you want to deflect a heavy object, you're going to have to do it, which is tumbling, you're going to have to do it impulsively, okay? Not with electric propulsion, with either missiles, with conventional explosives or nuclear explosives, blasting off mass from the side of it and giving it a nice shove, okay? That can be done. That's planetary protection. If we're talking about asteroid science, if we wanted to sample a variety of asteroids, that's done much better with a variety of small spacecraft. If we wanted to understand the larger composition of major asteroidal objects, that's either done with a robotic spacecraft or humans sent to the asteroid. But you have to, if you want to learn about real asteroids and not just rocks, you got to go to real asteroids. And then finally, there was another, in situ resource utilization has been advanced. That we can use this rock as a source for space materials that could be used in support of other space operations. Well, the essence of in situ resource utilization is you want to use the resources that are available in the place that you actually want to go to. If you had a lunar base, you would want to know how to use the resources on the surface of the moon, near your base, use them to make rocket propellant to fly back from the base. If you're on Mars, you want to learn how to use Martian resources to support flights up from the surface of Mars. But a rock in a retrograde lunar orbit is inconveniently placed to provide useful resources to anything other than operations at that rock, which has no intrinsic interest. So I think that this mission represents the wrong kind of thinking, and I do not think it has any rationale in itself other than it will give certain constituencies something to do, okay? And rather than looking to give certain constituencies something to do, we should figure out what we want to do and do that. Okay, so that's my basic position, and that's how the space program needs to go. So, would you care to rebut?
Sure. So, I'm a little, well, maybe I was going to say I'm a little surprised that you know, sending people to Mars, I think most people would agree is an expensive endeavor. And part of the problem of sending people to Mars is a transportation problem. And far from this asteroid retrieval mission being a mission designed for giving the EP community something to do, it's really designed as a stepping stone to develop the transportation technology that would make future human exploration missions more affordable. And the fact that we can, if NASA does this mission, actually pull that development earlier in time would then help support, make human missions to Mars more affordable. Because the experiment that you've been running so far is not happening, it's not affordable. And this is a way to help improve the affordability, because this is the problem. NASA's had this problem forever, and it's not going away. If you look at the way the Skylab program was done, that program went through huge gyrations because of budget problems all along the way. And so budget problems at NASA are not new, and this is not likely to change. So looking for more affordable ways to do this in the environment that we currently find ourselves, which is the development of the SLS and Orion, and that is likely to continue, is my understanding. And how do we inspire the community to give human spaceflight something to do that's affordable in a reasonable time frame?
Okay, once again, to give them something to do. Okay, the problem is that we're looking for giving them something to do rather than telling them to do what we want them to do. Okay. Look, I'm not against electric propulsion. If there are missions that we want to do that electric propulsion supports better than other forms of propulsion, then electric propulsion should be employed in those missions, okay? But missions should not be invented for in other words, moving 500-ton rocks around, okay, it's moving rocks around, okay? Whereas, for example, okay, if you can get the mass and cost advantages from electric propulsion by saying to deliver payloads to Mars, either by having the electric propulsion spacecraft actually push this payload all the way to Mars from low Earth orbit, or, as I believe is a preferable mode of operation, simply using it to lift payloads from low Earth orbit to very loosely bound Earth orbits, sure, where they can be destabilized and dropped right back very close to the Earth to a very tight perigee, and then given a small chemical kick and sent out to Mars on a home and transfer, minimum energy ballistic orbit, with the electric ferry just staying in operation in the Earth system, 1AU, where it has plenty of sunlight. If you can show advantages in either of those mission modes as a way of sending payloads to Mars, then we could use electric propulsion for sending payloads to Mars, and we're interested in sending payloads to Mars. And for instance, if you wanted to send, an Atlas can lift around 15 tons or something to Earth orbit, but only send maybe 3 tons on trans-Mars injection. With a system like this, in principle, if you can meet all the mass targets and so forth that have been identified, you might be able to send 8 tons on trans-Mars injection from an Atlas. Deliver much more payload and deliver a bunch of spacecraft to Mars, or larger spacecraft to Mars with the same launch vehicle. That's an advantage. I think that that would be a good use for electric propulsion. As part of a space exploration program which is planned around its own objectives, and which, in other words, the mission comes first, and then if various technologies, if they are the best for that mission, well then by all means make use of them. But don't invent missions for the purpose of giving technology something to do. And don't, and then also, once again, the problem is we've got, okay, the SLS, which is really very similar to the REs, which was put forward as part of the Constellation, was a heavy lift vehicle to do a moon program. So now they have a heavy lift vehicle, but without a moon program, or a Mars program, or a bona fide asteroid program. They've got a heavy lift vehicle without a mission for a heavy lift vehicle. And they have an Orion, which is bigger than you need to simply send crews up and down to the space station, and smaller than what you need for a true interplanetary habitation spacecraft.
Right. Hence the asteroid retrieval mission.
To give the wrong tool something to do.
And the electric propulsion. So we're in complete agreement.
Okay. Well, what I'm saying is you have either the wrong tool set or an incomplete tool set to do something meaningful. And that if you wanted to do asteroid missions, you could do it with the SLS and an Orion and a HAB module. Okay? And then you could do real asteroid missions. And that would be a subset of the technology you need to do the Mars Direct mission, where you could have the capsule, a HAB module, then you also need landing and ascent systems. But and you've got your mission. But once again, to try to create a simulacrum of rationale, it's like this. Imagine 2 couples who want to build their dream house. Okay, couple A sits down, they talk about what kind of house they'd really like to have, okay, and then they hire an architect, they sit down with them, so this is the kind of house, the architect sketches it out, this, that, gets it together, they look at it, and they say, yeah, that's it. And then they hire a construction contractor, they give him that design, and he goes and builds that house. That is the right way to build a house. Okay, the other couple goes out to garage sales every weekend and buys things that appeal to them as might someday be useful as parts to a house. Okay, so they pick up some aluminum siding, a spiral staircase, a fountain with a statue of Napoleon in the middle, some Doric columns. Okay, they pile all this stuff up in the backyard. And then what happens is the father-in-law comes to visit, and he says, why do you have all this junk in your backyard? And he says, well, we're going to build a house with it. He says, I'd like to see the plans for this house. And so they hire an architect and they say, look, we need you to design a house, okay, but it's got to use all of these parts. Okay, and that's how NASA's proceeding. Okay, that's the problem here. There isn't a plan. They're proceeding without a plan. They're proceeding randomly, okay, with, okay.
But here's just to give you a different analogy, you know, so.
Audience participation was
Oh.
a stated thing.
All right, we'll let him answer me, and then we will open it up.
Okay, so here's a different analogy, and so say someone said, I want you to buy an electric car and drive it from here or from LA to San Francisco. Okay, so you could do that. You could say, okay, I can get a Tesla, they got charging stations along the way. I can do that, but I can't afford that because that's, you know, it's like a $100,000 car, and so that's what I really want to do. I'd love to do that. I agree with you. We should do that. I can't afford that. I'm stuck with a Nissan Leaf, and all I could do is drive around my neighborhood and go round and around my neighborhood. That's where we're at. And all we're doing is going round and around in low Earth orbit. We'd like to go to Mars. We'd like to do lots of things, but you know, unless you can change the climate, I mean, right now, you know, I agree. I'd love to do all those things, but I don't know how you change the political climate.
Okay, well, look,
sure, but I was giving you a different perspective.
Okay.
That you got to be able to. The country has to be able to afford these things, and right now we haven't been making the case to change the political climate to afford all these
all right,
things.
so we've stated our positions, and now we will, as promised,
Sorry.
open it up. You take the first question.
Okay, my question was, I seen your presentation earlier on the solar electric propulsion, and you talked earlier about the larger scale and how many solar panels they were going to take. And I got to thinking, if you had this like humongo array of solar panels and you put some thrust in the middle of them, you're going to have some structural support, or the thrust is going to try to leave behind the solar panels. So you're going to have some mass out there. And is it viable? I mean, is it self-defeating? All the mass of the panels themselves and the racks they're going to have to be on to take the loading of the acceleration. Are you going to have a net gain there or a net loss?
Sure. So, yeah, there's a. You know, it's hard to imagine how electric propulsion actually works, but the acceleration of the vehicle is quite low. It's on the order of probably 10 to the minus 3 Gs or so. So the acceleration, you will not have a significant load on the solar array. Where you could have it, though, is if you, in certain architectures, as Bob said, if you thrust at perigee in Earth orbit and you have big solar panels at that time, then you can put a tenth or maybe 2/10 of a G into the arrays, and that's a lot harder thing to deal with. But the thrust from this electric propulsion system is a non-issue, even on very big solar arrays.
Okay, just as clarification, I was not suggesting that one thrust with chemical propulsion to push the electric propulsion system around.
But in case you did.
Yeah, all right. All right, let's get other questions or comments from the floor. In the red shirt over here. Sir, you.
Going to the asteroids than going to Mars. And I agree completely. Do I need to be closer? Okay. I know you didn't like the asteroid mission concept prior to Mars. I know the mission, agree completely about the mission driven, that we failed to do that. We failed to do that for years and years and years. So given the reality, that may not change. The way that this asteroid mission does, it kind of gets that whole asteroid thing out of the way so then we can focus on going to Mars. From a practical standpoint, the Obama administration has said Mars is the ultimate destination. It's first an asteroid, then Mars. Okay, so if you do this asteroid mission and they check it off their box, even though, like you say, it's a lark compared to what they initially proposed, it still gets it out of the way, still get onto Mars. You do have the SLS, you do have the Orion. They are pieces of getting to Mars, even if they're, not a really, they're a very incomplete set. So doesn't it at least provide some value as a stepping point to get us moving?
No, I think rather it threatens the existence of the SLS program. And I'll tell you why. Because if you say this is what we're going to use the SLS for, then you say, well, why not kill that too? Because since this isn't worth doing, and that's what you propose doing with this tool that we're paying you to develop, okay, maybe we shouldn't be developing that tool if this is the best you can come up with. The only reason why we need a heavy lift vehicle is to do human space exploration beyond low Earth orbit, to go to the moon, Mars, or the asteroids. That's why we need a heavy lift vehicle. We don't need a heavy lift vehicle to go up and down to the space station. You can go up and down to the space station with Dragons, and there you have it, okay? And you'll get all the urine samples from astronauts that you want. And but to do exploration. So either you're going to do exploration or you're not. Now, as far as checking off the box, I mean, this thing is actually putting the human spaceflight program in peril. We had a congressional committee vote forcefully no funding for this thing, okay? And then we're saying, but this is what we're developing the SLS for. Oh, well, right? I mean, look, NASA is really playing a risky game here. They're letting themselves be adrift in the face of an oncoming fiscal tsunami, okay, where there's going to be an imperative for budget cuts, and if you say we're building heavy lift vehicles but we don't really intend to do anything significant with them, okay, or, where's the manifest? Okay, what's the plan? Okay, launching one of these every 5 years? I mean, or if that, I mean, they need to start with, look, this is what we intend to do. We intend to take your pick. Okay, my pick is humans to Mars, but there's plausible alternatives, so I don't think they're as good, but I'll name them anyway, which is a moon base, a program to systematically explore the near-Earth asteroids, or humans to Mars. Okay, say that's what we want to do, and here's the reasons why we want to do it. And then this is the hardware set we need to do that. Okay, now, and that's what we need to do. Now, but I mean, I had a conversation with a person who's a longtime acquaintance, I'd say even a friend, but I'm not going to name him here because I don't think his comments do him any credit. I invited him to be on this panel. He is a strong advocate of this asteroid mission. Okay, and he told me we have to do this asteroid mission. It is enabling for humans to Mars. Now, really, no one ever heard of this thing more than a year ago. Okay, people had all kinds of plans for humans to Mars, and who would have imagined that moving a asteroidal fragment into a retrograde lunar orbit was a requirement for sending humans to Mars? Okay, I mean, it's a totally random thing, and now I'm not necessarily even arguing that there aren't certain intermediate missions that might rationally be included as part of the Human to Mars program. Okay, I think a case could be made. I'm not sure it's a valid case, but it's plausible that exercising part of the Humans to Mars hardware set on an asteroid mission or two is a useful way to spend part of the total money available as part of a Humans to Mars program, that might be a useful intermediate mission. to do, okay? And I mean, there's any number of and things you might do, but and then that might be more useful than using a heavy lift launch to pre-position extra supplies and equipment on Mars, or a whole bunch of robotic missions, or any number of other things you might do, okay? But I have to say, I just can't imagine that of all the things that one might do as part of a Humans to Mars program with a budget of X, that moving a 500-ton rock into a retrograde lunar orbit would be on the list. And so, you know, if you're going to do near-Earth asteroid missions, do near-Earth asteroid missions and explain to people why those are important missions. Okay? You want to do a lunar base, do a lunar base, and explain to people why that's important. Want to do a, you know, Humans to Mars, do that. But anyway, that, I think I've answered your question.
Yeah, how do you get them to do the mission specific?
What? Say this again?
How do you get them to do the mission specific goal when they just, we've seen it for decades, they don't do it?
Well, actually, I think that Obama gave them an opening. He said, I want to do an asteroid mission. But they didn't take it seriously. They never took that presidential call as a call for a program, rather than just as a vague, they let it be a vague vision to put sizzle on a non-existent steak. Okay, they say, well, we're going to do something. Someday we're going to go to asteroids, as opposed to the president has called for sending us to asteroids. Here's our plan. We can do it by 2016. Okay, and frankly, it's not that hard. A near-Earth asteroid mission is an easier mission than a manned lunar mission. It's much simpler mission. And he announced that in 2010. They should have gone to work, figured out how that could be done by 2016, by the end of the second term, and presented him with that as their plan, and pushed to do that. This is what you want to do. This is how it can be done, instead of just acting randomly.
Besides just capturing the asteroid, is there any other like benefits, like, you know, weaponization, or are there like other benefits that could be, you know, seen when we do this mission?
So we wouldn't turn it into a weapon. You know, this is a relative, you know, a very small object on the order of 7 to 10 meters in diameter. So it wouldn't make a very good weapon. Even if you targeted the Earth, it would burn up in the Earth's atmosphere and that sort of thing. But one of the, you know, Bob mentioned ISRU, in situ resource utilization. If you bring back the right kind of asteroid, and eventually, so you bring back a carbonaceous asteroid, one that has the potential to have hydrated minerals, then you have the ability to extract water from that. And of course, water, even in a distant retrograde orbit around the moon, would be very valuable as a source of a variety of uses for water, including splitting it into hydrogen and oxygen for propellants, oxygen to breathe, and so forth. And it is right now very expensive to move anything into lunar orbit. It's on the order of $100,000 a kilogram. So while ISRU isn't the near-term application for that, ultimately there could be a substantial benefit from that. NASA has looked at lots of studies at harvesting asteroids, near-Earth asteroids, for their resources, and always that is a transportation problem of first order, because you have to get to the near-Earth asteroid and bring back whatever it is you're going to bring back, and that's hard to do. And if you're getting the idea that a lot of these problems in getting around space are transportation problems, that's true, and that keeps us, you know, bringing us back to the need to develop advanced propulsion technologies, and the best one and the only one that's advancing rapidly is solar electric propulsion, and it's solar electric propulsion. So.
Cliff?
Well, any road you take will get you somewhere if you keep walking along it. But if you keep stopping and turning back and going in a different direction every couple of years, obviously nothing that you do is going to get you anywhere at all. So it seems to me self-evident that whatever mission you pick has got to be one which has a fighting chance of being accomplished within the time span of one administration. Because, as you say, not invented here, we're going to go do something else with the next turnover in political control. Whatever the last person did is obviously not worth doing. So that's one comment. The other one is that, well, I lost it.
You didn't say it fast enough.
That's right. Well,
But it was a good
I need
one.
to take lessons from you, Bob. Oh, no, I've got it back now. If we can go back to analogies for a moment, we're standing on one side of a door, and we can peek through the keyhole, and we can see paradise on the other side of that door. So, but we don't seem to have the key to that door. So rather than figure out how to open the door, rather than find the key, what we do is we try and whittle our dreams down small enough that we can fit them through that keyhole. And it doesn't seem to me that we would need to do that if we were as smart as we used to be about building things in a reasonable time on a reasonable budget. I take the SLS as an example of that. I mean, tell me that this is not a procurement problem. Looking from the outside, it seems to me that we could be doing a lot more with the budget that we have if we knew how to do procurement. Now, we have one person inside NASA, one outside of NASA, but you're still better experts than I am. Is this a procurement problem?
In part, but it's a procurement problem in the following time, where with both SLS and Orion, okay, they really decided to make a meal out of it, okay? And there are people I spoke to in conjunction with the Orion program in particular, and I said, why are you designing this thing so big? Why are you doing this? Why are you doing that? And he said, you don't understand. This is we might not get another big program like this for a real long time. So we need to, one of the requirements of the Orion program was that its development take at least 12 years and cost at least $10 billion and so forth. It's kind of like the space station in that respect. Okay, whereas they're trying to make a meal out of the thing. If in fact, I mean, look, Saturn V, they gave out the contract in 1962. It flew in 1967. It's 5 years, and we were inventing it as we went along. Okay, and it was flying people the year after that. And and here, right. But what I'm saying is, even today, we have programs, and I have to say they're primarily in the robotic area, although those are not free from waste. But nevertheless, nobody tried to make a meal out of the airbag program, okay, to make it be as long and as expensive as possible. It was part of an overall mission, and it was approached with, look, you have to do this within this time frame and this cost. And if the SLS was being pursued not as a thing in itself to give Marshall something to do, okay, but as part of an overall NASA initiative where you say, okay, we're going to return to the moon, and the whole program has to be done within $30 billion budget. And that means that the budget for the development of the heavy lift launch vehicle cannot be more than $8 billion. And the development of this other thing cannot be more than $4 billion, and so forth. And that's how this thing has to work. Then you can have a much more efficient procurement. But if you have these programs being pursued as things in themselves, and that each one is their own special banquet, in other words, it's like going to the store and spending money in order to give the store business, rather than going to the store to buy things that you need in the most economical way possible to get what you want acquired and done. That's the problem.
Yeah, and I'll just say, the asteroid retrieval mission by no means is intended to solve all of NASA's problems and solve all of the human spaceflight problems. And we're proposing a particular mission that allows NASA to make progress in human spaceflight given the environment that we currently find ourselves in.
Jürgen.
This mission is sold to the public with one of the main arguments being the future danger by asteroids. You have mentioned it. And I think I don't see by any means how this mission could be a preparation for this. I mean, one day or the other, the public will be aware that this mission, called Asteroid mission, will have nothing to do with saving the Earth from meteorites. Could you expand a little bit on that?
Yeah, so...
Or am I wrong?
Well, I agree that that wouldn't be and shouldn't be the primary focus of this mission. There are tangential benefits, and one of them is the observation campaign that's necessary to find and characterize these small objects will significantly improve the knowledge of the near-Earth asteroid population. So if you're looking for small ones, you will, by matter of course, find the larger ones that are potentially hazardous objects. So there's that tie into planetary defense. Moving a very small object like this, you're absolutely right, that is not by any stretch of the imagination a compelling demonstration of a planetary defense approach. And I agree with Bob that if you really were going to deflect a large, potentially hazardous object, the best way to do it is with some sort of kinetic impactor or explosive or something that gives you an impulsive delta V right away. Now, the problem with that is that the effectiveness of that depends on a parameter that deals with how effective that impulse gets transferred to the object. And that is largely unknown, or at least has a large degree of uncertainty. And so by bringing back a whole one, even though it's a fragment of a large one, because these are all fragments of larger objects, it will help inform, at least for one object, what the internal structure is. And that will help do that, give you some additional information. But it is not would not be the primary focus. If you really wanted to do just a planetary defense demonstration, there are other and better ways to do that than this one.
Okay, other questions or comments? Kai?
I'd be interested in knowing how you think this mission relates to what is publicly known about what Planetary Resources plans to do. I mean, they plan to find, characterize, and eventually bring back pieces of near-Earth asteroids for economic gain. Are we doing something that they will be doing anyway in a number of years, or are we preparing something that will make their job easier, or will they just do it with robotics and we'll have the samples to study without a big, expensive, multi-billion-dollar project?
Okay, so let me just clear up the last part. This is at least the initial mission is a robotic mission. The mission I described is a robotic spacecraft that goes out, grabs a hold of the asteroid, detumbles it, and brings it back. So it is a robotic mission. Only later do you send the crew up there when it's in the stable orbit around the moon. So Planetary Resources, of course, it's a small business, and they are a very long way from returning, samples from or mining asteroids. We've talked with Chris Lewicki several times, and they're a business trying to survive, trying to make money as they go along. The first thing they're going to do is fly these small telescopes in low Earth orbit. So they're just a very long way from being able to do that. If this helps them, and by bringing one back, it may be a way that they can test some of their equipment on this without having to go all the way out to a near-Earth asteroid. That might be of benefit to them. But we don't see this in any way as interfering with, competing with anything that Planetary Resources or Deep Space Industries would be doing.
Let me see if there's someone else. Over there?
So I'm too young to really understand this, but it seems like a lot of the great developments in the 60s were made in a context of conflict during the Cold War. Do you think that we need that kind of context again to be able to develop a proper mission?
I think what's needed is a mission-driven context. See, Apollo was willing to accept risk, okay, because there was a mission to be performed, okay? It was not an option of, well, we'd kind of like to go to the moon, but, you know, we don't want to do it until we know it's safe, which is sort of like the way they're approaching humans to Mars or to the near-Earth asteroid even, okay? And therefore you have an indefinite time because you'll never actually know that it's safe. This is not safe stuff, okay? I mean, flying up into orbit at, 8 kilometers a second on top of, very thinly built things that are filled with high explosive. That's what's needed. The people that did Apollo, yeah, there was the competition with the Soviets, but the generation that did it were the younger brothers of people that had landed on Normandy and Tarawa, and no one told them that it was going to be safe. It had to be done. It was mission driven. We're going to defeat the Axis. We're going to do this, and there's risk, fine, but we're going to do it. Okay, mission comes first. And, if I say right now, okay, does everyone agree that the primary criteria of design of a human Mars mission should be mission success? Okay. At Martin, we used to have posters on the walls all over the place. Our primary focus is mission success, okay? And it seems like motherhood and apple pie. Oh, yeah, sure, mission success. We always want to be successful. But you've got to realize that mission success includes actually doing the mission. Okay. That's part of mission success. And so if you have a NASA whose leadership has a different primary focus than mission success, it's safety, or actually more broadly, not looking bad. And that's what's missing. Okay, I think that a human Mars mission should be designed with mission success as the criteria. That means really doing it, and it also means if you think about risk, that mission success is more important than safety. So, for instance, let me give you an example of what I mean, a numerical example. Let's say you were the manager of a robotic Mars exploration program. You're going to land rovers on Mars, okay? And you have two alternatives as to how you could guide this program. You could do a great deal of testing and spend a lot of money on all sorts of technology developments and things, and you'd be able to launch one rover and you'd have a 95% chance of success. Or the alternative is you would do less such preparatory activities, but you'd have more money for a flight and you'd be able to launch two rovers, each with a 90% chance of success. Okay? Which is the correct decision? The second. If you know your math, it is the second one, because if you've got two rovers, each with a 0.9 mission probability of success, that means the chance of at least one of them winning through is 0.99, 99%. That's the better plan. And you even have an 81% probability of two rovers succeeding, which is impossible with a one rover plan. Okay, so so that's a much better plan. But on the other hand, if you think about it, if you were concerned about rover loss, the two rover plan is a much worse plan, okay, because you have, in fact, a 19% chance that you are going to lose one rover, and at least one rover, whereas the other one's only a 5% chance. So if you were doing a robotic mission program, that's how you would do it, the 2, the 0.9. Okay. Now, of course, if it was 2 with a 0.3, that would be an inferior plan to 1 with 0.95. Okay. But think about that. Now, I think if you're running a human spaceflight program, that's also how it needs to be done. The same logic, okay, needs to apply, because we're doing these missions at the cost of many billions of dollars. And it is true that if this money was spent outside the space program, it could save many lives. Okay? The highway department saves one life with each $3 million spent on highway repairs. Okay? There are programs for vaccinating children and so forth, which even are more cost effective than that, significantly. Okay, so we're not sending people to Mars to save lives. We're sending people to Mars to get people to Mars. Okay, and therefore the paramount criterion needs to be mission success. Now, obviously, safety figures into that, because once again, if the 2 missions each had a 0.3 chance, it would be inferior to the 0.95. But we can't do an indefinite number of preparatory activities in preference to a finite number of actual flights. Okay. Anyway, I drifted off your subject, but once again, the issue is whether you're mission-driven. Now, the competition with the Soviets formed a context that made this thing mission-driven. I think there's other ways it can be mission-driven than geopolitical competition or conflict. But nevertheless, the mission has to come first. That has to be the logic behind the program. We're out of time, and thank you very much.